Welcome to today's Explainer. So let's talk about something practically every Java developer is wrestling with right now, building production-oriented AI workflows with Java and Spring Boot. You already know how to build a rock-solid enterprise-grade application, right? Your controllers are handling requests beautifully, your services are enforcing strict business rules, and your repositories are keeping that data locked down. But then you get the inevitable requirement to add an AI-enabled workflow, and things just quickly go off the rails. How do you inject all this amazing model intelligence without completely losing control of your business rules, your security, or your ability to write a passing test? Well, that is exactly the puzzle we're going to solve today using a really structured architectural blueprint.
Here's our roadmap for today's Explainer. We'll start with the pain points of adding AI to Spring Boot, define what the AI Fabric framework actually is, and really dig into the all-important ownership boundary. Then we'll break down its layered architecture, trace some real-world request flows, and wrap up by talking about exactly when you should reach for this approach.
All right, part one, adding AI to Spring Boot.
Let's just acknowledge the messy reality of where we all start. When we try to haphazardly bolt AI features onto our familiar controllers and services, we almost always end up with totally scattered code. Calling a model to generate text is easy enough, sure, but a useful enterprise workflow? That needs way more than just a text generator. Without a proper framework boundary in place, these AI integrations grow into disconnected silos. You'll see one controller calling a specific model SDK, while some random service is busy stringing together prompt templates. Or worse, you might have the browser trying to guess what the user wants from a few keywords, or, and this is literally terrifying, allowing model output to write directly to your database. And testing? Forget it. You just end up verifying mocked wording rather than proving real side effects. Individually, these shortcuts might seem okay, but together, they create an unmaintainable, insecure system where failures are hidden behind canned bot responses.
Moving on to part two, defining AI Fabric. So what's the structured way out of this messy integration trap? Enter AI Fabric. Think of AI Fabric as sitting right there in the middle, between your Spring Boot app and your AI systems, like your LLMs, your embedding providers, and vector stores. It acts as a coordination layer. It adds the vital application-level AI capabilities that Spring Boot needs out of the box, like retrieval, governed actions, conversation memory, privacy, and provider orchestration. It's the glue connecting raw model intelligence to your real, governed application data.
Let's get incredibly explicit here so there's absolutely no confusion. AI Fabric is a modular Java and Spring Boot framework for building production-oriented AI workflows. But honestly, what it's not is just as important. AI Fabric is not an LLM. It's not a vector database. It's not a shiny new chatbot UI. And most crucially, it is not a replacement for your domain services, your repositories, or your authorization rules. It simply provides the contracts in the orchestration, meaning your app doesn't have to litter provider-specific API calls all over your beautiful domain code.
Which brings us to part three, the ownership boundary.
This right here is the absolute most important design rule of the entire framework. This is what makes it safe for enterprise use, the strict ownership boundary. Look at the divide. Your application, it continues to be the boss of the business truth. It owns the domain records, the source of truth persistence, the authorization, and the side effects. The other side, that's AI Fabric and the providers. The framework owns the orchestration and action discovery, while the actual providers handle the model inference. An LLM might figure out what a user is asking or suggest a valid action, but it absolutely does not directly own a repository right. A browser does not manufacture intent. This strict split is brilliant because it lets you leverage AI without ever treating the model's output as absolute unquestioned authority.
Now for part four, the layered architecture.
Let's peel back the layers and see how this operates top to bottom. Imagine a user request coming in. At the top boundary layer, your API receives natural language input. As it drops into the application layer, your own code jumps in, supplying the services, repositories, and verified user identity. Then it hits the AI capabilities layer. This is where AI Fabric takes the wheel to coordinate retrieval and enforce those strict governance rules we just talked about. Beneath that, provider contracts completely isolate your workflow from any specific LLM. So if you want to swap out your model tomorrow, you can. And finally, at the bottom, the concrete systems like OpenAI, local ONX models, or your main database do the actual heavy lifting. The framework doesn't hide these systems, it just neatly organizes them.
Another huge plus with this blueprint is that it's designed as a modular toolbox. You do not have to install the whole kitchen sink on day one. You start small. Grab AI Fabric Core and the Spring Boot Starter. If you need semantic search later, just pop in an embedding provider.
Heck, for local dev, you can combine OnX with Lucene and avoid needing an OpenAI key altogether. Need grounded answers? Add the RAG module. Want to let the AI trigger app operations? Plug in the action registries. Working in fintech or healthcare? Snap in the PII and chat session modules for strict privacy and memory. You literally only add what you actually need.
Okay, part 5, tracing request flows.
Let's ground all this abstract architecture in reality by tracing a real request. Say a user asks your app, "Why is my account blocked?" Step 1, your backend catches the authenticated request. Step 2, your app policy supplies the current user and tenant boundary because we never blindly trust a tenant ID sent from a browser. Step 3, AI Fabric figures out the workflow and retrieves only the approved policy evidence. Step 4, the provider takes that allowed evidence and drafts a response. The beauty here, if the evidence doesn't exist, the workflow exposes that reality. It stops the model from hallucinating some generic customer service answer.
Now, let's trace a governed action, which is where things get really cool. Say the user types, "Update my payment method." Step 1, AI Fabric uses the LLM to parse out that intent and grab the parameters. Step 2, it looks up the action specifically registered and allowed for this workflow. Step 3, here is the framework's safety net in action. If this changes system state, AI Fabric stops and kicks a confirmation request back to the user instead of just YOLO executing it. Step 4, only after the user hits confirm does an application-owned handler safely trigger the real domain service. The LLM suggests, but your code pulls the trigger.
For these flows to survive in a real enterprise setting, you have to aggressively guard the flow. Real chats don't happen in a single request. When a user replies, "Yeah, update it," the backend needs the context. So AI Fabric gives you backend-owned conversation state, preventing the browser from having to send trusted context back and forth. For sensitive data, the PII module spots and redacts info before it ever touches an index or hits a third-party provider API. And multi-tenant retrieval uses a failed closed access policy. Make no mistake, these are hardcore backend architecture concerns, not just clever prompt engineering tricks.
Finally, part 6, when to use it.
Zooming all the way out, when should you actually pull this framework off the shelf? AI Fabric is a fantastic fit when you're injecting workflows into a Spring Boot app that demand real application data, governed actions, conversation memory, privacy, and release-ready tests. It's built for those serious, deep integrations. However, if you look at the other side, if you're just writing a quick one-off script or hacking together an experiment that sends a single prompt to a single model without needing governance, skip this. A direct SDK integration is totally fine for that. Reach for AI Fabric when you actually need to tame real enterprise complexity.
Let this quote really sink in. AI Fabric keeps domain truth and side effects in application code while making model intelligence useful inside real workflows. That is the whole philosophy in a nutshell. It's about empowering you, the developer, to build trustworthy, dynamic AI features without sacrificing the rock-solid architecture you've spent so much time building. As we wrap up this explainer, I want to leave you with a bit of a challenge. Take a look at the Spring Boot application you're working on today. What's one requirement that could really benefit from an AI Fabric module? And even more importantly, as you map out that strict ownership boundary, what responsibility absolutely must stay locked down in your application code? Think it through, map it out, and maybe start with a tiny proof of concept. You'll be well on your way to building truly production-oriented AI workflows. Thanks so much for hanging out with me on this explainer, and happy coding.